Okay, let's see if this works.
Yeah.
Okay, and
Oh, there we go. Hello.
is there sound or not? I don't know. I can hear myself in the microphone.
Yeah, I just heard myself.
I'm just going to post a new link on just going to post it, update the link on Canvas, just in case anybody's coming late. And post a new link on biology, and where is meds? Did I forget to put an announcement on? No, there it is. There's the okay. Ah, there we are. Okay. This is good. Okay. Hi. I'm just going to turn up my microphone so I can hear myself. So there's how many have we got here? 52 watching. That's good. Yeah. So I don't know whether my stats on this window is the most up to date. So thanks for coming. The point of this exercise is for me to answer some general questions and try and go through the process that we want you to go through to look through data, make some comparisons, and also oh, hi, Erica's online. We've got some tutors online, Emma and Erica, so they'll have to answer some questions. The idea is that we'll be able to respond to some of the general questions. The questions I got in the form were mostly about working with the data, like getting a start on the project. So I'm going to have a look at that and go through like a whole process where we can start from this example shape. So I was able to come around to some of the classes and show this sketch here, which should be appearing on the window in a second. So if you can all see that, I think there's a few second delay that I need to get used to. So there's this sketch here that we have. Will I be able to rewatch this again after the streaming has finished, or is it just this? YouTube will save this, so we'll be able to. You should be able to access the video at this link.
Yeah.
So not the first one, but the one that you're at now. I've put that in a comment on the Canvas announcement. So I don't know, maybe I'll keep an eye on the other link and try and forward people there if they're still there. Please see new link above. Because I couldn't figure out, I started a an event, but I don't know why my streaming software isn't sending it to that event. It was supposed to just automatically start, so sorry about that. But today we're going to, well, this evening we're going to have a look at this sort of entire process of selecting one of these and modifying them based on data. So the first thing to look at is the data itself. So if we go to Canvas, I'm just going to bring a Canvas window up here. Actually, no, there was the Living Data Workshop 2. Sorry, not on Canvas. So I'll copy this link here into the chat. So this is Workshop 2 slideshow. So in there, you'll probably want to hang on to that anyway, but there's the data that you'll need is on this slide here, slide 11, and I'm going to copy this here. So data for this evening is in the Dropbox on there. And how about I'll add these two experiments. They're actually on Canvas as well, but I'll add them to that same Dropbox folder now. I'll make a live stream sketches, and I've placed them in there. So the Dropbox folder, once you download it, excuse me, we'll have these files in it. There's one called live stream sketches, and inside there's example shapes, and there's experiment 1. So experiment 1 is the one I worked on to build something in the workshop, and the example shapes sketch is what we're going to start off with. So that's these two sketches that I've got open here. So we're going to use one of these shapes from the template, and we're going to have a look at the whole process of going from one of these to something along the lines of this. Okay. I guess just if you have any questions, just type in. Emma's also still in the office, so she'll give me a shout if there's a question that I need to answer. And I think I'll just get going because there's a bit of a delay. So any questions will come in, I guess, as people have them. So I've mentioned it a few times, but there's I'll open a new window. I'm going to go to the website datasketches. Datasketch.es. I would normally zoom in on this, but I can't, so add a link to it. I can't zoom in on this application, but if we go right down to the bottom to the movies section, there's example of, this is all examples of the process that we'll be looking at, but this is the one that we get this flower pattern from. So if we have a look at what their process is, they have a week just to look at the data over a month, a week to hand sketch things, and 2 weeks of the month they develop these ideas into code. So we're going to not spend a week on each of these. We're going to have a look at this process. So the first thing we need to do is look at our data and what we can compare. I'm going to open up Photoshop, and instead of using pen and paper so you can see what I'm sketching, let's open Photoshop on this window. Here we go. And I'm going to create a new blank something. Okay, so if we think about the data that we have, there's where's my mouse gone? No, my mouse has been playing up a little bit. There we are. So we have a few things to look at. We have activity. My handwriting's not usually this bad. And we have nutrition. So for each of these, there is a so for this is like we have the self for each, and we also have the group data as I get more into the hang of using this pen again. So as well as this, there's also for the activity there's steps and what they call a mean activity, like an average activity over each row, an average level of activity, and the steps is per minute. What that means is if I in the Dropbox folder, I'm going to open the actually I'm going to open my own data, and we can see that there's a mean activity and there's also steps average per minute. So per minute, it is for the minute by minute data, it's the average number of steps that you took over each minute. That's a bit that makes sense. So in this row here, I did 44 steps per minute, but for the hourly data and the daily data, it actually is the same value. So during this hour, I did 12 steps per minute as an average over that whole hour. So we've also got so that's for the yourself and for the group. There's also the proportion of time which of that row, so of that minute, that hour, or that day that you were sedentary or doing moderate or doing light or vigorous activity, and also whether like the proportion of that time that it estimates that you were sleeping. So again, this is for both of these. So there's a lot of it's the lowest quality video 480p, highest. Why is it such low quality? I can set it, no, only to 480. My stream settings are not doing that as far as I'm aware. My output resolution I might just hang on. I'll leave my I'll go to another scene and I'll Okay, so you should still be able to hear me. I think I can change the... seems like I can't change that from my end. Maybe it's YouTube that's doing that. It says my stream health is okay, not great. Okay, so anyway, so we have the... There's not much I can do about that at this stage. So we have sleep, moderate light and vigorous activity. So these are a proportion. So a proportion of that row. So these should all add up to 1, but it's what we call normalized data, so it's on a scale of 0 to 1. Then for the nutrition you have a whole lot of individual variables such as macro and micro nutrients, energy. So the activity data you'll have every day you can compare with the class, and the nutrition data you can only compare yourself with the class if you on certain days, because most of us probably didn't do intake 24 for the whole 7 days. If you did, congratulations, I'm kind of impressed. So those are the things that we've got to work with. So we can see things that are more easily compared than others. I closed my palette. So there's some things that are easy to compare. For example, comparing steps per minute is pretty easy, because we have... Do we have to compare ourselves to the group, or can we focus only on ourselves or only on the group? You can do whichever you prefer. So you can compare yourself to the group if you would like, or you can compare yourself to over the week. So you can look at changes, you can look at differences in the weekend or during the weekdays if you would like, or something like that, but it's totally up to you. But that means that there's a lot of questions that you could ask from this data set, right? There's do I want to compare macro and micronutrients, or compare energy to, say, my fat intake or my intake of carbohydrates, for example, to try and give an idea of what proportion of energy you're getting from which kind of source. So there's a lot of questions that you can ask, and it's totally up to you. So there's so much variation, and there's so many of these different templates to start off with that we can build something that's pretty unique each. So let's have a look at these example shapes. So I've got all this data that I can compare. So how about I look at let's have a look at, so we have an average activity. Where's my pen gone? So I've got my own average activity, and I can have a look at energy in as well on certain days. And let's open up a data set and have a look at that. So in the demo data in there, there's some demo data for intake 24, and there's some hours data. So we'll work with the hours data because it makes these kind of patterns that have a bit more going on, and we'll also use intake 24. So this is mostly, I'll do this so you can have a look at how you could use 2 data sets in the one sketch if you would like. So I'm going to open this one in Excel, and if I zoom in you should be able to see more. So I'll have a look at the mean activity, the average activity, and I'll use that column and perhaps the average steps per minute. So we can see here that there's when there's no steps per minute, there's not as much activity. How about I go down a bit further during the middle of the week? So this one had 70 steps per minute, and this level of activity was a bit higher. So I'm just having a glimpse just to see what the data is going to do. And so we can see, yes, when there's no activity, there's also very little average energy expenditure. So I can kind of read this on Excel, so hopefully you guys can follow along as best you can. Part of me thinks it might be the university network, but we'll have a look at that. So hopefully that's readable enough. So what we might do is we might start with one of these fairly simple sketches. Does anybody have a preference for which one of these ones, like row 1, number 1, 2, 3, or 4, or 5, that you want to work with? And I'll show you if we can start with one of these templates and we can have a think about which one we would like to. Bottom left, this one. This one I think is actually the reverse of this one above. So that's why it's pointed and round at the end, I think, from memory. Bottom left might be an interesting one to look at. So, so the way that these templates are organized, I've got them organized by row. So row 1, then there's a few for loops. And then there's a big comment that says row 2, and then there's a couple more, and then row 3. So I've just made num rows equal to some random number. Can we just use line graphs? You can. There's no. We don't have as many templates for line graphs if you would like to use line graphs, but that's fine. So, do we want to use bottom left or first on the right in row 2, the end one, the pointy one? So let's have a look. The pointy one has 3 variables to look at, and the next one is that one there. So if I change this number of rows to like 4, we'll see what that shape is by itself. Oops, I've got 2 copies of processing open. So that's the shape it's drawing, which is a bit complex, but that's why we've got all those lines there. Let's change that back to 24. So this example shapes, I've made it so, yeah, that's why there's so many lines there. So I've made it so it can be, you can just change anything that's assigned to a number and see what happens without breaking anything. So this one has a lot of values. You can leave these as they are. You don't have to change them, but you can't delete any of them. If I didn't want to use this distance offset 5, I'd have to go down here and delete whatever point it's creating. So This one has a lot of points to play with. So outer radius, if we make that 260, we can see that it makes, wow, has that effect? That's interesting. 160? Okay, that's what that does. Distance offsets, angle offsets. So these are all just controlling the way that this point changes. So if we change angle offset 5, we can see that suddenly it's turning around for some reason, and we can just play around with these. How about this pointy one over on the right? Might be a better one because there's fewer points to mess around with. So I'm gonna distance offset. If I make that 10, then we get the T of this kind of star shape moves right in the middle. So I'll change that back to 50. Angle offset, if we make that 10. So that just makes the width of that T sort of shape bigger or smaller by the look of it. So if we make it 90, they'll overlap heaps. That looks kind of cool though. Distance offset 2 is 100. If I make that 10, I think that might be the outside point. I'm going to make this back down nice and low. So you can see here that the first part is to sort of figure out what it is that's happening with these sketches. 70. So if I have 120 and like 40, what does that look like? So you get like a nice wide area for this colored section. And this is kind of cool. I like this sort of inverse of this design in the middle. Perhaps we can draw a circle behind that to give it a different color on the inside or something like that. But first things first. First thing we want to do is, I'm going to use this pointy one. It's just a bit less complex than this one, the bottom right one. So I'm going to copy this entire for loop. So there's a lot of white space around each one, so it should be pretty clear where you cut and paste. So I'm going to copy this into a new processing sketch. I need a processing window open to open a new processing sketch. I'm gonna... Sorry. Okay. Sorry for jumping around there. Paste. So there's no number of rows yet, so I'm going to close this old example shapes, and I'm going to work with this one. So I'm just going to add in num, an integer for num rows will be equal to, say, let's go 24. We're going to look at hours data. It's 24 hours in a day. And my sketch, which I'll just drag onto this window. Obviously it's tiny. And first thing we need to do is change where the center of our circle is. So we can go like width over 2 and height over 2. So this is doing something crazy here. Let's make our sketch a lot bigger. So we use a size function. We've seen this one before. Let's make it 500 by 500. Just arbitrarily big. And we can see, yeah, we've got a sketch there. Now, you'll notice, the first thing you notice is that you can really tell that these are drawing over the top of each other, whereas when we were looking at the example shape sketch, they didn't really have that effect. That's because we've got a really low opacity on the fill color. So just to make it look a little bit prettier, I'm going to add in a background. I'm going to make it white. Is it clearer if I use white or black? I'll add in a white background and I'll add a fill color, and I'm going to make it a little bit of red, a little bit of green, and no blue. And maybe I'll make this text a bit bigger so it's a bit clearer. And I'm going to add another value for the opacity, and I want that to be quite low, so I'm going to make it like 70. I'm just going to play around with this value. That looks kind of dirty brown, so let's turn the green up. Get our green on. Okay, so it looks a bit green at the moment, but we have 24 rows, and now we've got our for loop just running with these extra 4 lines of code that I've added up the top. Someone named Living Data has logged on. Is that... do we know who they are? And how did they find out about this stream? Did somebody create a Google account just to watch this and call it Living Data? So we've added...
Tom.
Oh, it is Tom. So Living Data is Tom from the UK. So this is one of our experts who are doing a lot of the heavy lifting for processing the data so you can all use it. So thanks for logging on, Tom. So question, when do we need to set up a canvas before we draw the sketch? So if you're... okay, that's a really good question. I'm not using the setup and draw functions. Just to start, I'll just start a new sketch. So we saw in the examples for processing there was like void setup, which runs once, and void draw, which runs repeatedly. This is optional. We introduced it to you because that's how the helloprocessing.org sketches work. You can use this if you would like, but if you don't use this, it just runs through everything once. It just runs through everything once, and it gets down to the end and finishes. So if you're using the void setup and void draw functions, you need to have the size as the first line in your setup. I think processing will complain. It'll give you an error if there's anything in the setup that comes before this size function. If you are doing it without using the void setup and void draw functions, then it's fine for you to have a couple of things in front of, but it's best to do it at the start because you can't draw anything until you tell the sketch how big it is. So that's a good question. It is important to have it before you draw anything. So having it as the first line is the easiest way to do that. So we create a sketch that's 500 pixels across and 500 pixels high, and we have this number of rows, and rather than using that, I'm going to use my data. So I'm going to close my little Excel, minimize my Excel spreadsheet. I'm going to, from my demo data, I'm going to drag in the hours, and down the bottom here, you probably can't read it, but it says one file added to sketch, and I'm going to now load that. So I'm going to decide there's going to be a name for this data. So it's going to be called, it's going to be of type table, and it's going to be fills activity. You could call it whatever you like. And we're also going to load the data from this CSV in here. So we're going to use the load table function. And then I'm going to copy and paste the file name into there. And I need to have this header parameter here as well. Does it matter whether or not we use the void, draw, and setup functions? How do we decide whether or not to use it? For this one, for this sketch, you don't need to because you're just doing a static visualization. So if you were drawing something animated, you would have to use the draw function and probably the setup function. If you are doing something, making a still image, then you don't need to use that. Probably it's less work if you're just copying and pasting out of the templates. If you're just going to, excuse me, if you want to use, if you don't want to use the draw and setup functions. So this one, you probably don't need to. Okay, so we were recalculating our number of rows. So I'm going to make an integer. I'm going to call it num rows, and I'm going to make it equal to fills activity dot get row count. So this will count how many lines there are in this CSV file, and it's going to save it as the number of rows. And when we run this, we can look that there's like zillions and zillions of these icons that it's drawn. So the questions that have just come in, how do we choose which shape we want to use? You mean which of the example shapes you want to use? If you just figure out which one you think looks prettiest and you want to work with. It's entirely aesthetic. Thanks, Erica. And the other question, why we need the header. So in my CSV file, my data file, this top row is what we call the header. Okay, so this is it isn't the data itself, it's a description of what's in that column. So it's something useful for us, but it doesn't, it doesn't count towards the actual data. And it also tells processing when we are going through not to read that row. So we've loaded our number of rows into this variable called getRow, using getRowCount on our activity data, and we've suddenly ended up with all these points here. And the workshop material has some a little bit of code that you can copy and paste into your sketch to adjust the center position based on what day it is, which is a very useful thing to be able to do. I'm going to type it out here, but basically what we want to do is move the center of the pattern that we're drawing. So let's start off first by seeing what happens if we just change these values. So if I make width over 2 0, this the center X moves all the way over to the left, and if I make it the value of width, I can make it all the way over on the right. So I might want to map the day it is to this value. So I'm going to, the first part of data I'm going to load from Phil's activity is going to be the current day. And it's going to be an integer. And I can do this because I think every single one of the data sets that we're looking at actually have a column called day with a capital D. How about I open it up in Excel so it's a bit bigger. So this here is the current day. So for each hour in that first day, it's day 0. Each hour in the next day, it's day 1. And it goes up to 6 because there's 7 days. So I'm going to have the current day will be equal to Phil's activity. And this is the pattern that we saw in class. We're going to get row I. Because we're inside the for loop, we have this variable I that we can use, and it's going to count through all of, count up to the number of rows. And we're going to load, sorry, that was wrong, get int from a specific row, and I'm going to ask it for the row called day with a capital D. So I'm just going to run this, and I've still got my center X being width. I haven't updated that yet. So I'm going to have our X coordinate is what I need to update. So I'm going to save it as a variable called X coordinate. You don't have to use new variables for everything, but because we're breaking this down, I'll just do that. So I'm going to, this X coordinate needs some value, so it's going to be a float. X coordinate equals some value that I'm mapping. So I want to map the current day, so I'm going to have current day. And currently, well, to start off with, the current day is on a scale from 0 to 6. Okay, it's the highest we can go up to. So it's on a scale from 0 to 6. And it's going to go up to, let's say, 0 to width. So the X position, the biggest one we want is over here. And we've got this kind of like, it almost looks like frames from animations. Is day of the week, with 0 being Monday. Tom might be able, 0 is Monday, yeah. Thanks for answering that one, Tom. It's the same with the hour of the minute. It's within a week. That's good that it's all lined up. So the other question that came up, why is processing telling me that the file does not exist or can't be read? If it can't be read, it may be because I would guess that you're on Windows and you've got your data open in Microsoft Excel. This is a really annoying problem with Windows, is that if it's open in Excel, it won't let processing read the file at the same time. So if you drag it onto your processing sketch and open the original file, it should be fine, because then your computer's got 2 copies of it. It's just one of those things about Windows, and there's not a lot we can do about that. Yeah. So now we have these dots appearing across the screen. I'm going to make the sketch a lot wider. I'm going to make it like 1500. So these are more spread out. And I'm going to do a little trick that we did in class in the first week with our line chart, and I'm just going to reduce the size of the area that we're mapping to. Instead of starting over here right on the corner, I'm going to move it in 100 pixels, and I'm going to move it in 100 pixels this way by mapping from 100 to width minus 100. Now this is all in the workshop materials as well. Okay, so when I run this, I can see that these are all spread out nicely, and it looks kind of cool. It looks almost like it's being like an old school cartoon animation that I've just lined up all the cells for. But we can see here that currently in from the example shapes, we want them all to fill up the shape that we're drawing. I think this is actually closed, so I'm having a problem where processing isn't closing my window. And that's just one of the things about using Mac. But we can see from this example, the original template we started from, these are all spread out evenly based on the number of rows. But we have a lot of rows, and we've now spread them out. So the next question is, how can we make these all line up nicely? There's a very simple fix, and rather than mapping our angle from I, our current row number, to number of rows, we're going to map it to the number of hours in a day. Does that make sense? So each day, so this is one day here, this is the next day, Wednesday, Thursday, Friday, Saturday, Sunday. And there's 24 hours in a day. And now we have these shapes all lined up nicely. We could, if we wanted to, map them to 12 and do maybe something doubling over. If you're comfortable with if statements and things like that, you can say that if the hour, load the hour, and if it's, and figure out, but I'm not going to go into that because it's probably a bit too much for this activity. So my angle, rather than being mapped from the number of rows, I'm going to map it to 24 hours. So each 24 hours it goes around. You'll notice that the hour doesn't go from 0 to 24, it actually keeps counting up. So it will most likely be a series of images. Yes, probably. You could do... the question was, the sketch will most likely be a series of images. Probably. You could use, have all 7 days represented as one, but if you're doing like hourly data, then you'll probably want to split them out or have like something really narrow. So now we can start tweaking kind of the baseline values to see what sort of ranges we want to map our data to. So if I make distance offset really big, I'm going to add a 100 to it. Okay, that's that kind of inside T line. I'm going to make this one only a little bit bigger than distance offset 2, will be slightly bigger than distance offset 1. So I'm just tweaking values just to see what happens. Let's make it 90. Okay, they look nice and even. Let's have a look at what angle offset does. Let's make that 10, and we get like kind of really nicely separated. And if I make it, actually 10's not a bad number. I think that's a good proportion. And let's make this one really high. Okay, so we can go all the way up to like, let's go to 89 and see if that still looks. So we've almost got like the inverse of one of those other shapes that we drew. I'm going to turn it back down to 50. I'm actually going to make a note of ranges that sort of work. I'm going to open Photoshop. I'm going to open a new let's call it a sketch pad, I guess. So we have distance offset, angle offset, and distance offset 2. So if I can find where my, so we have distance offset. We want that to be from, let's say, 20 to 80. So we can move this further and closer to this point. Is 20 too close? So there's a lot of this iteration, and this is kind of the way that processing was made to be used. Make a small change. I think 30 would be a bit nicer. Yeah, so we can still see some colors when it's at 30. So let's go from, let's have this being 30 to 80. I'm not used to drawing with my my little pen here. We also have angle offset. That's at 10. We'll keep that at 10 for now. We won't map any data to that. And we have distance offset 2. So I'm going to distance offset 2. I'm just going to make a note of this. So 90 is a good number, but if it's like 190, that's the outside, so they'll overlap a bit much. It's 120, that's still too far. I think 100 will be as far as we can go. So 100 down to 40, maybe we could map some data to that. Oh, so that changes the scale of the whole thing. It kind of works. But this one, I don't think it'll go a bit crazy if it gets bigger. Oh no, that still looks alright. So if this one's going 30 to 80, why don't we say this is 80 to the maximum we'll make that is 100, I think. Okay, so I'll just make a note of this. So this will be 80 to 100. It's supposed to be an arrow there. Okay, and then we have color to work with as well. So we've got a few things. So this, we can load in some data and see what this will do. Now, in my other sketch, what did we decide to look at? Average level of activity compared to energy intake. So Phil's activity is the name of my table. So I'm going to, first thing I want to do is load in the average activity. So float activity. We don't want to make it too long for our variable name, but we want it to be recognizable. I'm going to go back to my spreadsheet. So the column name I want is mean activity in G's, in G forces. So I'm going to copy and paste that into my Phil's activity.get row I for the current row, and I'm going to get float from there, and I just copy paste that header name for that column header. Now you will notice that I had current day is getting an integer, and current activity is getting a float. I have to use a float for this mean activity, this average activity level, because it will drop everything after the 0, and because this is what we call normalized data, it's on a scale of 0 to 1. Oh no, it's not. It's not normalized. It's just that I didn't have more than 1 g-force constantly over an hour. Anyway, my bad. But because it has a decimal point, if we load an integer, it will just drop off everything after the decimal point. You have one shape. So Matthew Chen has one shape that runs in the middle. So there's, in these two lines here, fix that. And they're in the workshop material for workshop 3, and they're on page 7, I think. Page 8 in the PDF, which is labeled as page 7 because there's a cover page. Okay, so my average activity, I'm going to map that to some value in order, and let's move our middle line here based on that average activity. So float mapped, let's go map activity equals the map of average activity from a scale of 0 to something, to 0 to something else. Now I need to I can make a decision about this. It wouldn't be a good idea for me to use 0 to 1 here, even though all the numbers are less than 1, because I think the maximum will be something like 0.2. I could look through and compare them myself, but as we've seen in a few other examples, we can use a little for loop to figure that out for us, and we can save it as a variable. So I'm going to make a new variable outside of my for loop called max activity. I'm going to make it a float, and I'm going to make it equal 0. It's a float because it will have one of these values put in here, and they will be floats, so we need to have it as a float. And we've got a for loop that we can loop through to find the maximum value for every row. So we've seen this a couple of times before. We've seen this in workshops, and we've seen this in some of the other pre-work activity. So I'm just copying this for loop, so it's going to be the same. We're going to use I to loop over every row in our data set. Today's activity equals so I'm going to get the current row from my activity, and I'm going to get a float from this mean activity column. And I need to remember to so this is a temporary variable, and this is going to be our one that we keep forever. And then I'm going to assign max activity a new variable, and it's going to be the maximum of max activity and today's activity. And I'm going to print the value of the max activity is max activity. So this is going to print out something just so we get a little bit of feedback. So it's 0.29. So I could have probably looked through here and found that, but if I was working with the minute by minute data, there's no way I would have bothered doing that, because it's 60 minutes times 169 hours, so it's not worth my while. 170 hours actually, because it starts at row 0. And so our max activity is now the highest number in this column, wherever it was. So rather than, so I'm mapping our max activity, we're going to map it from 0 to our map. We're going to map this, our average activity for this day, to this. We're going to save this value. It's going to be our activity from the row that we're up to, mapped from this scale, and we said we're going to have it to distance offset, and I can't remember, lucky I made a note of it. Where's Photoshop gone? So our dist offset is between 30 and 80, so let's go 30 to 80, and we should see each one of these has something different. No, we don't, because we need to use this map activity. Unterminated string constant. Jackie, what does unterminated string constant mean? I got it as an error message. It probably means that you left out the quotes, I believe. So somewhere when you've typed in a column name, you need to remember to close off your quotes. And it should turn purple in processing. Matthew Chen, the other thing to remember about moving these across, I don't know when that question came up. Ooh, there we go. Is that you need to actually remember to change the value of your center X to this value for X coordinate. Only one shape's appearing in my window. How do I make more than one flower appear? I don't know. It says today's activity cannot be resolved to a variable. Is there a typo somewhere? That means that if I, for example, instead of max activity, I have max activivid. If I have some kind of typo here, that's the error that you get. It's probably a typo. Jackie L. Only one shape is appearing in my window. How do I make more than one appear? Are you following along with us? There is a make sure we've mapped our day and to the right input and output if you're separating them, and then change that to the X coordinate, and then we can have a look. So these few lines are in the workshop material for for workshop 3. And yeah, the angle one is as well. So we have a little visualization. We're actually showing some data. So we can see here that there was a lot of activity at this time, quite a bit on Saturday afternoon. This doesn't look like my data. It's the demo data. I wonder if it's Emma's, because she went raving, I mean to a music festival. And it's kind of cool, like when you're doing less activity, it shrinks in, and these actually become smaller because this angle becomes bigger as it moves out. So the days that you got more activity becomes more obvious. What else were we going to add into our visualization? Average activity and energy. So we could have... Emma's just caught up. You guys are a little bit delayed, so Emma just started laughing at my raving comment. Most of my comments this afternoon have been pretty raving. Okay, Jackie L's got some... code that she's got a question about. I'm going to copy and paste this into processing, into a new sketch. So this is the code that Jackie's put there. I'm going to press Command T and have a look at it. Male mean activity in G's. That means that you're using the aggregate data, which is in the class data folder. Gender by, let's say it's gender by hours. Male mean activity, G. So, I know what you need to do. Today's activity needs to have some kind of type. You need to tell it that it's going to be a float. You don't need to do that with the maximum. So if I go back to my one, so when I created my maximum activity value, I told it was a float, so I don't need to do that down here again. But today's activity needs to have a type. Processing, some other programming languages let you get away without including that, but processing is not one of them. So we've got a little visualization. I think we'll keep it simple, but we'll add some color. Let's add in a little bit of color based on... I've done a lot with being sedentary, but why ruin a good thing? So this is all we've changed so far, this little bit here we've been playing around with. I could load in other columns to map to these values, but I think you get the point. Mapping to color, let's have a look at how we would do that. So I create a fill function, and I'm going to have a value R, G, and B, and I need to make those variables. So float R, float G, float B equals 0. I'm just going to make them all 0. Oops, semicolons, and I'm going to make that one 255. So this will fill the inside of them to red. And I'm going to make it nice and translucent, so it's not quite as dark. So this works. We can change the color, but again, we want to have some nice data-driven values. So let's say let's go back to our data. So we've looked at our activity, and we want to look at the number of steps that we got. So the average steps per minute. And let's say we want to map this from So the average steps per minute will need to have some kind of scale like we had with the activity. We'll need to get the max number of steps, and maybe we can also load in another one and have a look at using these ones that are proportional, so they're just on a scale of 1 to 0. Maybe I could look at how asleep someone was. That'll be interesting. So first, to go over the steps, we're going to have a float max steps equals 0, and I'm going to go through a similar process to what I did here. So I'm going to have float today DODAYS steps equals, I'm going to be naughty and copy and paste, and I'm going to get the correct. So the reason I'm copying and pasting, I won't ever change any of these header rows. Some people think, oh, I don't want to put brackets in, and they delete the word like proportion or something like that. But when it looks like, when they look at this, they just type in light activity, but there's actually a space after. So it's just easier, and you will avoid mistakes if you just leave these as they were. Sorry, you can't read that where it says light activity very clearly. But the point is that we don't need to remove those the bits in brackets from those headers. They're useful for us when we look at the Excel spreadsheet, but they're a pain if we leave a space on the end. So we're going to have max steps equals the maximum value from max steps, and today's steps, my terrible typing, and so we know that this will work. We've used this a couple of times before in our examples, and I'm going to do something similar down here. We're going to have a float for the steps for the current row will be equal to so we're going to load the steps average per minute for the current row from Phil's activity. Okay, and then we're going to create another variable, map steps equals map. Let's map our steps from 0. I could take 0 steps to max steps, and let's map it to a color range. So let's have it red when there's lots of steps, and let's go yellow when there's not a lot of steps. Actually, now that I think about it, I should really encourage you guys to save often. I just realized I haven't done that with this. Because my computer lagged for a moment and I got really nervous that I'd lost everything. So we're mapping, we've loaded our steps for this row. We're going to map it to some value. And we'll have it yellow when there's low steps and red when there's high steps. So I'm actually going to save this to use this for map steps for my green value. So the 0, the low steps, equals a lot of green. A lot of red and a lot of green makes yellow. So as this decreases, red will stay the same, so it'll still say red, but the number of steps will go. When it gets closer to max steps, the green value will drop down. So you can see here that there's a lot of steps on this one. I'm going to make this maybe 150 so it's a little bit clearer. So we've got quite a red little star here, and we've got yellow stars when it's a bit calmer. And let's turn up the blue whenever we have, whenever we're asleep. Okay, so this one is a little bit easier to work with. So our float sleep will be, I'm just going to copy and paste this, but I need to change the column to the same as this column that I want to look at. And I'm just going to have, so as we've said before, sleep is on a scale of 0 to 1. So I'm just going to have sleep times 255. So this is actually, what this does is, we've got a number multiplied by 0 to 255, so it's, when we're not doing a lot of steps, it turns yellow, but we're not doing a lot of steps and it thinks we're asleep, it will actually turn white. So there's a few examples where, a few sample spots where we can see it thinks that it's sleeping around here. So now there's a bit of tweaking that we can do. Maybe I don't want this to be such a red kind of red. Maybe I want it to be like a 205 instead of a 255. That just makes the whole thing a little bit duller, so I could perhaps, I'm just going to add 40 on here so that blue is always kind of 40ish. It makes everything a little bit bluer. So there's a lot of tweaking of these values again, especially if you've mapped multiple values. Let's make this 225 and always have it down to 100, so there's always a little bit orange rather than red. So this is just tweaking values. Maybe if I, what does it look like if I change the background to black? Oh, that's kind of cool. I like that. I can change my stroke to white. That's a bit much. How about I change it? How about I just don't have it? I like that. Looks kind of cool. But we'll probably need this to be a bit brighter again. Let's change these back to 255. They're still a bit dark because they're not quite solid colours. But I think this white and yellow and orangey red looks kind of cool. So it appears orangey red instead of bright red because this only goes down to 100. So there's always a bit of green. If you're asleep, there's all the blue, so it appears white, and there's always lots of red. So this is kind of cool. I'm happy with this. The only other thing we wanted to look at was including how much energy you took in on each day. Now, I'll need I need a second for loop for this. And I'm just going to add a few elements down the bottom here. I just want to add like a couple of dots down the bottom to, or maybe one in the middle to show for the days that I ate something or that I logged the nutrition. I think this is demo data. I'm going to grab this one and put it in. For the days that I logged some nutrition, how much energy did I take? I can actually, because I'm not using begin shape, end shape, I can just put all this down the bottom here if I wanted, but I'm going to load my table up the top. I'm going to stop scrolling up and down and giving you all motion sickness so you know where I'm up to. So I'm up the top of my sketch. I'm going to have table food intake. Do we have to look at all the aspects, sleeping steps, etc.? Could we only look at one? One isn't that exciting. You could have one and some related ones, but if you can have a really cool idea showing just one, that would be alright. Wouldn't be an issue with that. Yeah, I think you should probably look at more than one. It would probably make for a more engaging visualization. So I'm going to quickly load my food intake. And I'm going to make an integer food rows rows equals food intake dot get row count. And then after I've drawn this whole lot here, I'm going to just add another for loop. For I in I'm int I equals 0. I'm thinking about the wrong programming language there. I is less than food rows. I plus plus. So that's correct. Food rows. Yep. And I'm going to get the maximum amount of food energy intake. So there's a column in here called, I'm going to zoom in so it's a bit clearer for you guys watching, energy, and I like kilojoules. I don't know whether this is the latest demo data or not, but it's the one that I'm going to use. So I want a variable called maximum energy, and I want that to be a float because our kilojoules have a decimal point equals 0.0, and we've seen this before, right? So we what did I call my food intake? So today's row energy intake equals food intake dot get row I dot get float from the column called that I copied and pasted from Excel. Again, sorry Windows users that you have to keep closing this, and this is going to be a float. And so maximum energy will be the max of maximum energy. That sounded like a really cool name for a variable before I'd started typing it so many times. So now this is going to calculate the maximum energy. We've done this a number of times, so we can go on. I'm going to make another for loop. I is less than food rows I plus plus. Okay, so one loop to compare them all and one loop to draw them. Let's have just a simple dot, and let's have an ellipse. There's like x coordinate for that ellipse, y coordinate for that ellipse, and let's make it like 10 by 10. So we'll have a fill color of white, and we need to populate these values. Where will it be? I'm just going to be really cheap, and I'm just going to use something similar to what I did here, except rather from loading from Phil's activity, I'm going to load my data. Rather than from Phil's activity, I'm going to get the current day from food intake. Right, because we're loading our food day rather than our center X, center Y. So let's load our food data and let's put a dot on the days. No column called day. Isn't there one called day? Day in week. I think this is an old version that I've downloaded because I think it's now called day. But it's called day. In this version, it's called day in week. Maybe I didn't type that correctly. Oh, there's no capitals. Day in week, all lowercase. Again, your mileage may vary. And I've got a dot on the days that have some kind of energy intake, which is kind of cool because I can now do fun things with it. Let's make the internal color of our ellipse, let's change that based on the energy. That's pretty simple. We can fill. We can load the energy from the current row again. I'm just going to copy and paste that from above because our live stream's gone on for a while and we can get this done quickly. So energy, let's map. How do I want to do this? So float, our R value will equal, I'm doing this all in one step. Mapping energy from 0 to max energy? Maximum. I regret that decision. Energy. So that's the scale that our energy is from when we load it. And it's going to be on a scale from like 200 to 255. Let's make it 100 to 255. And float G equals 0, no green. Float B equals, let's make it the same thing. And our fill will be R, G, B. And let's make it like, let's not change the opacity, let's have it nice and bright. Just to have a look. And we've got these purple dots. So the intake of energy for this one wasn't very low. I have a feeling that this is day 4. I don't know what happened with I didn't finish intake 24, so it only thinks I ate like a tiny amount of kilojoules. I think I started it but didn't actually save it, or I kind of saved it and went off. So this is the reality of what happens when you start playing with data. You get values like this, which is much lower. So unfortunately, there's not a lot of change we see here. This one's a bit duller than these two. Then we can play with these values. Maybe I want it bluer than red, so I like it, make it red go up to 200 and down from 50. Didn't really see a difference there. New error message from Jackie L. This table has no header, so no column titles are set. Except the table definitely has headers. When you loaded it, did you put header in there? Did you add the header to the load table function? I don't know. Is that what that error is from? I'm going to delete that and see what happens. This table, yeah. So it looks like you just forgot. So it's not that the table doesn't have headers. It's that you forgot to put that in there. Yeah. So, just glad we're all doing this together. I'm really happy that there's some of you coding along. This is great. I'm going to do something really quickly that's kind of fun. Maybe, I'm not going to talk through it, but I'm just going to finish off with this. I'm going to have a nested for loop. I'm going to Command T to neaten up my code, and I'm going to have J there. J plus 100. Okay, now we're going to have a look at this. I put a comma instead of a semicolon. And I'm going to have this kind of, not ellipse, I want a, this is just a little bit of fun. And these can both be J. Too big. 80? 50. Okay, now we have like a glowing dot. Okay. Stroke weight. So, for those of you who want to be a bit more adventurous, this is what we call a nested for loop. So we've got a loop within a loop. It's, rather than using I, we use J, and it's constructed the same way, but with J's instead of I's. And I'm using this to draw an ellipse with an outline color, so it gets dimmer and dimmer as we go around, and with a center point in the middle of each day, and it just fades out. So this one, so it has a different effect. Actually, I think there's actually two circles here looking at this data, because it is old data. There's two on day 1. Oh, sorry, day 0, hour 1. I'm not quite sure, so that's why this one's brighter now. I think that's just because I'm using an old data set by accident. So, those of you who stick around for the end might want to have a look at, you can draw these faded circles that kind of fade out by having no fill color, a reasonable stroke weight, and having a stroke that reduces. So there's going to be some that are invisible because the alpha's higher than, it goes lower than 0, so you won't be able to see them, but they go out to around here somewhere. So that's a really quick look at drawing based on data. Now what we need to do is add the last line. This is also in the workshop material. There is one line you can use. So if you're not using the for loop, the draw loop dot png, you can do this without, you can just add this line. If you are using the for loop, you just need to have a slightly longer line you need to have this line here. So this is outlined in the workshop materials, but then you can click the screen to save a copy if you like it. This one will always save over that file. So there we go. So that's our file created. I'm going to save. I'm going to press Command K to open, or Control K in Windows. So that opens the folder here, and that's where my output PNG is. So all I need to do is describe what I for the processing PDF. There is a I'm going to open the marking rubric in just a second. So is the code submitted along with the image in the final PDF? No, you do not need to submit your code. So there was no there's no requirement to do that. So if I've added, so both of the workshop 2 and workshop 3 and 4, the last 2 living data workshops both have a link to the marking rubric. I'm just going to bring it up for you. And here it is. As long as it doesn't ask me to sign in, we'll be right. So you just need a single PDF file, which you can create in Word or something like that. And as long as it includes the image, a short research question. So I wanted to compare how much, what were we looking at? The average steps per minute, but also show when it thought that I was asleep. And compare that to the energy that I consumed during the week. Then you need to have a justification. So I would say I used the column with this name for my energy intake. How about I go up to the top and do this in order? So the first thing I did was I used my hours data to represent each hour, to get the data from each hour, and I selected the mean activity column, the steps average per minute column, and the sleep proportion column. I mapped the outside radius of my shape to the mean activity column data, and I mapped the steps average per minute to create the change in color, and also the proportion that I was asleep to a change in color. Okay, so 300 to 500 words should be plenty to describe that. Oh, and then I added a circle that includes the maximum amount of energy that I consumed. So 300 to 500 words should be sufficient for doing that. What do I need to do to my code to make 2 rows of 7 shapes? Ooh. Okay, I'll do this quickly because that's kind of an interesting question. So the angle needs to be mapped from...
So, just one of the questions that Drew's answered, they do submit the code with them?
No, you don't submit the code.
Oh, I thought you did submit the code in
No,
the PDF.
Drew's answered, no, you don't.
Oh,
No.
okay.
Sorry. So let's really quickly have a look at how to do 2 rows. So I'm going to map, the angle's going to be 12 hours, so we're only getting 12 of these things, but half of them are on top of each other, right? So, actually this looks kind of cool. But we need to adjust our center Y, and there is actually another little thing that we haven't learned. I was wondering whether I should show this to you, because it's not too complicated, but it is a little bit complicated to understand. There's a thing called modulus, which basically divides any variable by a number and gives you the remainder. So I want float current hour to be Phil's activity dot get row I'm just going through quickly. Get int hour. So that's going to give me an integer. So I need to have this as an integer. And my y value, how am I going to do this? So if current hour mod 24 is greater than 12, I'm going to have an else. Okay, I'm just going to put this together and then I'm going to explain it. This may work. Maybe I got that number wrong. Sorry. That one? Center X, center Y. Oh, ER. Okay, really quickly. So it's messed up my energy dots, my energy balls. I'm not gonna say that again. Okay. 80. Right. What this is doing is a little bit complex, but and a little bit different to what we've seen before. So the top row is how's the best way to explain this very quickly? One row of set. Okay, so I'm getting the current hour from the data set. So that's just a number that counts up and up and up and up. So this one is the kind of the thing that makes it all work. So I'm giving the height of my center Y to be height over 2, which is the middle, plus 80. And then I've got an if statement. So if whatever this is true, it changes it to down here. So so hour 0 will be down here, actually. So this should be less than 12. They should be swapped around. So hour 0 will be this one down here, probably, if I've done this correctly. And so basically what this does is it creates a center position, and if this is true, it changes its value. Okay, so that's just moving it up and down. So what this does, I'll make a new sketch and I'll just use the print line to just show what this is. So we've got, let's have 3 mod 5 and let's print that out. Print line 3 mod 5. So we've got 3 as a result, and let's go 13, and it gives us a result of 3 as well, which is kind of weird. So what this does is it divides, so x mod y, so the percent sign is what we call modulo, so it divides x by y, and rather than giving you the value, the answer to this, so print line 13 divided by 5, it gives us the remainder. So 13 divided by 5 is 2, with 3 left, with remainder 3. Okay? Thank you, Ashley. Thanks so much. I feel 100 better, 100% better about processing situation now. That's good. That's what this was for. I'm so glad that that was someone's result. When's the final version of our data visualizations due? 1 week after, the week after your final workshop, on the Friday midnight. So it will be in 2 weeks for Stream A on Friday night, so 2 weeks and 1 day, and 3 weeks and 1 day for Stream B, or medical science, because medical science is already is all in Stream B, I believe. Yeah. So, great. I'm happy that you're happy. I'm tired, and I need to go home, because I'm still at the office. Once you get to the end of the first training, you press the position, reset the exposition. Okay, Drew's still there. Thanks, Drew and Emma and Erica and whoever else was answering questions there. Thanks, you guys, for watching. But I am going to head home now. I'm going to have a check in a couple of days and see how many people watched the stream and all that kind of stuff. Whether people found it helpful. We might do another one in a week or two, maybe, and see how you guys feel about this. If you have any feedback, yes, Jackie, we'll have to revisit this video. Yeah, so that's why we wanted to do this, because not a lot of you could make it to the times that we had the face-to-face drop-in sessions, so it was a waste of our time. Whereas we have 28 people watching now, and we didn't have that many people show up to our drop-in sessions in total, and we did like 8 of them. So hopefully this will be something that some other people find useful. And thanks all for watching, and I'll see you in the next workshops.